Okay, so today I'm going to discuss about 4500 Catalyst switch. This is 7th session on the switch platform. Now
रत्नेश भाई आपकी
why
आवाज क्लियर नहीं आ रही बिल्कुल भी. हेलो.
discussion topic today is 4500 Catalyst switch, and we'll see that how we can troubleshoot this particular switch. Now why I started this particular topic today in the Nexus class. The reason behind this, if you see the history of the switches, so initially we have switch called 2960 or 2950. This particular switch was something like, obviously this was manageable switch, but it has some ports and it is used at the rate of access layer. After that, in the same line you have 3K series, so you have 2K series switches and 3K series switches. After that, Cisco has introduced some modular switch. So in terms of modular switch, you have 4K and 6K, where you have the concept of supervisor engine and you have line cards. And then the next generation is Nexus. So in Nexus also you have the same modularity. Now in Nexus platform, either you have Nexus 7K or 9K like chassis based platform, or you have Nexus 5K something like 5596 or others. So 5596 are something like a single line card type of switch. Now this is very important to understand the generation of the switches and the technology to decouple data plane and control plane. So what does it mean by the decoupling of the control plane and data plane? That means that you need a single control to control all your switches inside your switch domain. That means when we are talking about 2960 switch, at that time we have a concept of a stack. So we have a stack cables connected like this. That means we have one control plane, either switch number 1, 2 or 3 according to their stack priority, that will become the engine or the brain of the switch, and that particular switch will control the other switches. So whatever configuration you want to push from the control plane, it will automatically write it to the other dependent switches or the dependent stack members. Now the same type of control and data feature we have seen in case of either 4K or 6K. So in case of 4K or 6K, you have the concept of VSS, virtual switch system, where you have a single control. So you have one control plane and you have dual data channel. So you have some control and you have dual rate. So if you see physically they are two switches, but logically they are single switch. Now the next generation switches like Nexus switch, Cisco has changed the concept of this VSS and they introduce VPC. Now both are very different type of features. VSS is very different, VPC is very different. VPC is nothing but the virtual port channeling. The whole idea behind the VPC is to do the ECMP, equal cost multipathing, because these switches are data center switches. So inside data center switches, we need some equal cost multipathing from east to west. We are not focused towards south to north or vice versa. So we are very much focused about the traffic that is going from east to west, that is from one data center to other data center, and we want to extend the layer 2 capability of the data centers. So we are focused on the east to west traffic. So that's why we have the feature of VPC. Now there is no harm to understand the troubleshooting of VSS or the 4K, 6K, because by the end of day These are switch. And whatever the characteristics of switches you have means what switches are doing. They are taking their decision with respect to layer 2. Now, in the modular switches like Nexus or 6K, they can work as a layer 3 gateways as well due to their different type of feature cards. So they are rich. They have rich feature set, like they have features like OSPF, BGP, all these features they have, and other feature they have that they have very solid TCAM. So inside this solid TCAM, they can have data related to IPv4, IPv6, QoS, ACL, and Netflow. So they can accommodate MAC addresses related to these features. So they can use as a layer 3 device as well. Apart from that, you have other features like you have VPC or VSS and all these things. But by the end of day, they are switch. So whatever feature you study in 2960 or 3850 or 3750, the same features you have in 6500 or 700 Nexus switch. The thing is that some syntax will be changed, some commands will be changed. The internal architecture of all these switches, because these are the access layer switches, so they are the cheap switches. So in the access layer switch, you have less RAM, you have less buffer, you have no backplane. So you don't have backplane in these switches. You don't have any fab module, that is the fabric module. So they don't have gigs of speed or teragigs of speed. If you go to the next generation of switch, then you have all those features, like you have the backplane, you have high throughput, you have supervisor engine as a brain to maintain the switch. So that is the one reason I want to discuss about this 4500 switch architecture, because so far we have discussed about the Nexus 7K architecture. So what is the architecture of Nexus 7K? We have seen that we have a small interfaces. So these interfaces, if I am specifically talking about M line cards, these small interfaces, they are mapped with certain ASIC. So they are mapped with local ASIC. Now these ASICs, they are going to either forwarding engine with respect to L2, L3, plus they have lookup to the replication engine. Now again, once they take all this decision, they map to some central ASIC, and finally they map to the fabric ASIC. So we have the abstraction in terms of we are taking the frames, we are putting those frames into the ASIC. Now these ASICs, they are sending their header information to the forwarding engine for different lookups, maybe IPv4, QoS, ACL. In case of layer 2 lookup, they are doing the IGMP lookups or MAC addresses lookups. Then according to the credit of the ASICs, they are doing the forwarding decision. Now if you see the 4500 architecture, you'll find some similarity, that you have interfaces, they are mapped with some memory. Obviously they are mapped with the ASIC. They map with some memory as well, and then they map with the central ASIC. Now instead of this forwarding engine, you will find that in this platform you have processing unit. So whatever layer 2, layer 3 decision from ASIC, the header will go to the processing unit, and this processing unit, actually in 4K, they are either K2 based or K5 based or K10 based processing units. It depends upon what type of SOUP you are using. So you are using SOUP 5 or 6, or you are using SOUP 7 LE or maybe 8. E. So it depends upon what SUP you are using. According to the supervisor engine, they have divided their processing unit. But obviously you have ASIC, you have memory, that is the buffer. They are mapped with the processing unit, and then you have the central ASIC, and then the packet will go out or they will come in. So moreover, either it is a Nexus switch. This M2 architecture is a bit difficult, but F architecture is very easy. So either it is a Nexus architecture or it is a Catalyst 4K architecture. You have some interfaces mapped with ASIC, you have some processing units, some memories, and then you have central ASIC. So these are the things you have to keep in mind. So I'm going to start this Catalyst switch. There is no harm to learn this Catalyst switch while we are learning the Nexus. So it will help us to understand the Nexus forwarding engine as well. I have one very good Cisco Live presentation. The ID number is, you can see on your screen, 3142. This is one of the best document for 4500 series troubleshooting. And what is the agenda for this particular troubleshooting section? Now this is, I think, some old slide. So agenda for this particular 4500 troubleshooting session is to understand this Cisco Live presentation 3142, and the goal, you can see here what is the goal. So understand the troubleshooting steps beneath this architecture 4500 or maybe 4900 series switch, and what are the things I'm going to cover in this particular. Obviously it will not happen in one session, it will take 2 sessions. So today I'm going to cover some very important things related to interface link, high CPU, iOS XE, crashes, iOS XE license, and these things I will cover in the next session. Now these things are day-to-day basis. You will get cases related to interface issues and high CPU and crashes and licenses. And here you can see the series of 4500 architecture. So you have 4510 as well, and you have probably this is 4507, probably this is 4506, like that. Now in these particular switches, you can see that they have this SUP LE. So you have SUP L, you have SUP LE, you have SUP 8, even you have SUP 5 as well. These are very old supervisor, SUP 5 and 6. Nowadays we are using L, 7L or 7LE, or we are using 8E. So let us focus on these portions only. But yeah, you may have supervisor 5, 6. Now this is the architecture. Now if you compare with the Nexus architecture, you will find, oh my god, this is nothing. So interfaces are mapped with the ASIC. This is the line card view, and then this is the supervisor view. So now these line cards are mapped with the supervisor engine, because in these particular platform you don't have DFC cards. DFC cards that they have their own processing and memory. So whatever decision these per packet basis they will take via the supervisor engine. Means the supervisor engine is the brain for this particular architecture. So whenever the frame has to take decision, either it is L2 decision or L3 decision, the frame or packet will go to the supervisor engine. Supervisor engine will check here in forwarding engine for L2, L3 informations. Then it will send to the packet processing unit. It has shared memory, and then TCAM, CPU and all these things, and then it will go to the egress direction. Now it's very important to understand one thing here, that 3750, 2960 and this 4500 switches, they have the same type of architecture of shared memory, and they have same type of architecture of QoS as well. It's a very similar architecture because they have the shared memory architecture. Okay, now this particular series of switch, now you can think that the iOS, they are running iOS XE, and the same iOS is used inside 3850 as well. So 3850 is also using iOS XE, and we'll see the architecture of 3850 as well, but it's easy. So whatever 2K or 3K platform you have, their architecture is easy. Whenever you have concept of line card and the supervisor engine, then you have some complexity inside the architecture. So we can see here that this particular platform has a supervisors. So they start with something like 2 plus to 6E, 7LE and 7E. This is bit old presentation. Now we have 8E as well. They have a transparent line card, and because these are the access type of switches, so they have some special type of line card. Those are PoE enabled. So directly you can plug the phones to those PoE devices and they will get the power from that particular line card, and it depends upon the particular no, the capability of that particular line card, that how much maximum power, means how much maximum number of phones you can connect with those particular line cards. So we'll see that chart as well. Then they have the switching ASIC, so packet processor, forwarding engine. These are the switching ASICs. Then they have their specialized hardware, something like TCAM, ACL, QoS, L3 forwarding, Netflow. So whenever TCAM will come, you think four things you have to remember: IPv4 packet processing, QoS, ACL and Netflow. These are the four factors, means these are the four features or services who are utilizing the TCAM. So if you are getting cases related to TCAM exhaustion, you have to check show platform system resource utilization. So you'll come to know that how much TCAM is used by all these services. Now one by one I am covering all these slides. Let me go to the next slide. So interface, high CPU and all these things I'm going to cover. Again, this is very important for the troubleshooting point of view, and you will get more information on this particular official guide. And this is the guy who is like expert in switching technology, Kevin Wallace. You have YouTube videos as well for this Kevin Wallace, and he write this book, CCNP Troubleshoot 642832. And you will get his videos for switching technology, some old videos. Those are really very good. Okay, so when you are doing the troubleshooting, you can use two approaches. Actually there are three approaches to do the troubleshooting. Either you can go from bottom to top, or you can go from top to bottom, or you start from somewhere in the mid, or you can go to top, or you can go to bottom. So what does it mean, top to bottom or bottom to top? So sometimes you feel that whenever you are doing the troubleshooting, you are doing troubleshooting something like this. So first you will ping certain destination, then you will trace route certain destination, then you will try to check show IP ARP, means what is the IP address and what is the associated MAC with that particular IP address. Once you find the MAC address of that particular IP, then you are checking what is the MAC address, and you are checking which interface has that particular MAC address, or maybe MAC address, and you can pipe and include whatever MAC addresses are. Means what are the interfaces or the VLANs who are learning that MAC addresses. Once you know that interface, then you go to that interface and you check the counters on that interface. So this may be a physical interface, this may be a VLAN, this may be a tunnel interface. This approach is something like top to bottom. Means you are starting from layer 3 and you are checking towards layer 1. So this is one approach. Sometimes we are using this approach. The other approach is that you are going from the L1 to L3 or maybe L4 or L5 or L7, whatever. Regarding interface. So how we can get the information about the interface? So I'll show you that I have some switches in my network. I'll show you that. Give me a minute. So how could we get the information about the interfaces? Means which interfaces are binded with which MAC address, or how the MAC addresses are learned inside a interfaces or inside a switch, that we can check. So I have one topology here. I'll show you the topology. On that particular topology, I have two Nexus switch and I have one layer 2 switch. Nexus 1, Nexus 2. And in this, how could we check the MAC addresses? And apart from that, in the MAC address, how could we check the BUM traffic? BUM is nothing but the broadcast, unknown unicast or multicast traffic. So these are the three type of traffics you will get on the interface, inside the interface. So how could you check the BUM? Now it's very easy to check the broadcast traffic. So whenever you are seeing that the traffic, the frame actually, the frame destination is all F, that means it is broadcast. Whenever you are checking that the frame source is something like multicast MAC address, and it's very easy to identify the multicast MAC addresses. So multicast MAC addresses has some specialty. If you see that particular MAC address, you will come to know that is the multicast MAC address. So with the help of source MAC address, you can identify that this is particular multicast frame or not, and unicast will know. The best possibility to know all these things, what you can do, that you can capture with help of Wireshark. So if you capture with help of Wireshark, Wireshark will tell you everything. Now inside the switch, how could you identify that particular interface has what type of traffic? You can use show IP traffic, or you can check the counters. So if you check the counters, show interface counters with that particular interface, suppose gig 0/0, so it will show you the average broadcast traffic, the multicast traffic, or the unicast traffic. Now the problem with this particular command is that they are showing the average. They are not showing the real-time traffic. Okay, so they will not show you the real-time traffic. That is the problem. This thing is very good in the Juniper switches. Inside the Juniper switch, let different methods. Either you can go top to down, or you can go down to top, and you can track different MAC addresses, and you can check the interfaces. Now if you categorize the problem in terms of troubleshooting steps, you'll come to know that either it is hardware issue, or it is a software issue, or it is a config or design issue, or it is a traffic. So hardware issue means your SFP is faulty, your line card is faulty, your supervisor engine is faulty. Transient hardware means it may be transient issue like parity issue. So sometimes the board, that is FPGA, field programmable gateway array. Maybe they are set to 0 or 1, so at that time your line card or supervisor will not work properly. Or maybe you have hardware limitation, say your TCAM limitation is something like 128K, but due to lots of IPv4 and QoS and ACL traffic, the TCAM utilization is overutilized. So at that time you have some hardware failure or issues. When it comes to software bug, you may find there are lots of bugs with each and every release. So it depends upon the customer environment, and this bug is very important. I'll tell you one thing about this bug. Generally, as a troubleshooting engineer, we are not advising the customers to use something like 15.1 or 15.2 or 15.3. We are not telling them that use this or this or this. Why? Because all of these softwares, all of these iOS XEs or iOS, they have some feature plus, they have some feature minus. Means according to the customer environment, whatever their design engineers, they are looking, oh, I need some less QS, I need some more ACLs, so ACLs are more, QS are less, I need some less IPv4 routes. So they are suggesting either you can use 15.1, 15.2, 15.3. You may have bug with this, this and this. All the releases has bug. So whatever things are running in the customer environment, whenever we are suggesting to upgrade or downgrade the iOS, it's very critical to understand that they are running that service for last 2 years on that particular platform. So it's very important to ask this thing to the customer that have you done any change? Have you done any recent change? Have you added some switches in your network? Have you done any design thing inside your network before you are suggesting any iOS upgrade or downgrade? It's very important. Okay, so please be aware about the thing that have they added some new server in their infrastructure, means they required some more throughput. Have they added some new IPv4 routes in their core switch? So these things are very important while we are suggesting the iOS upgrade or downgrade. It's not that you are hitting some error and you check that error in the bug tool and then you're suggesting, oh, this is affected by 15.1, so you can go to 15.2. It's not that easy, because in 15.2 they may have some other bugs. So be very careful whenever you're suggesting the iOS to the customer. Okay, they may have misconfiguration, they have miscabling as well in terms of hardware hardware design and reaching capability. Now these things are design type of things that they have so many guidelines for this, how we are doing the configuration, how we are doing the designing. They may have DOS attack, they may have some traffic pattern change, they may have bad peer service, something like that. So these things are, you will find, whatever cases you will find, they will fall in these 4 categories: hardware issue, software issue, config design, traffic. Now as a engineer, when you got the case, you don't know. So what is the category of the problem? And that is the first step of the first stage of the troubleshooting, is to understand the problem and what are the possibility. So these 3 steps are like very important. What is the problem? Gather the facts, gather the show tech, show log, error log, iOS information, their topology diagram. So these things are very important. You have to gather the logs, you have to gather the topology, any error, any recent change. All these things are very important in step number 1 and 2. And third, according to your logs, you can think, oh, this may be hardware, this may be software, this may be design, this may be traffic, but still you have to do some sort of troubleshooting, and that is coming under the action plan. So you have to create the action plan. While you are creating the action plan, you must know all these 4 possibilities. Anything could happen. While you are going on WebEx in the live production environment, you are executing the action plan. So at that time, you don't think that, oh, this thing. make your plan, be ready, and then execute. Even sometimes we are sending the action plan to the customer. So these are the action plan A, B, C or D. So if A will fail, we'll try to B. If B will fail, we'll try to C. If C will fail, we'll try to D. If everything will fail, then we'll die. Okay, so you must have all the plans and you are sending the action plan to the customer, and according to that you are doing the troubleshooting with respect to all these four category, and then you have to observe the result. So suppose you identify the problem, then you have the action plan. So according to action plan, you have done the implementation and the problem is resolved. After that, you observe for at least 48 hours or maybe 3-4 days. And then if everything is okay, then it's okay. So that is the life cycle of a ticket that you are getting. So whenever you are getting a ticket, then you have to follow all these things. Okay. Let me go to the next slide. This is the same thing that I told you. You have to caution when you are using the debug. So please do not use debug for anything unless you know about the debug. Suppose if you are using debug netdr, I will tell you what this will do. I don't know, maybe all or something, debug netdr all or something. At that time, be very careful. There are some debugs that you can use. So you can use debugs like elam captures or some other embedded Wireshark capture, but you can't do like debug IP traffic or debug ICMP, something like that. Please do not do that. If you know what is the potential impact of the debug command, then only you can use that. Then only you should use that. Now, let me go through this particular topic, that is the interface link, and then I will wind up today's session. This is the overall architecture, and in this particular architecture, now in the troubleshooting area, you must know that where you are troubleshooting. You are troubleshooting with respect to interface, you are troubleshooting with respect to ASIC, you are troubleshooting with respect to forwarding engine, you are troubleshooting with respect to CPU, you are troubleshooting with respect to memory, you are troubleshooting with respect to some iOS bugs, or you are troubleshooting with respect to some hardware. So be sure that what you are troubleshooting, because for interface we have different command, ASIC we have different command, forwarding engine we have different commands, for CPU we have different set of commands, for memory different, and for all these things we have different error log. Okay, so suppose in this particular example I am troubleshooting here on the interface level. So what is the state of the interface? So what I can do here, I can check show interface and then gig 0/0. If we execute this particular command, we'll come to know what is the status of interface. So I have one switch here. Let me go to the switch and let me execute this command. Give me a minute. I'm going to start my switch, and you can see in your PPTs that what are the things that we are checking. So is the interface is up or down, is the interface is flapping, or the interface is has some drops, no link. Basically you can check layer 1, layer 2, layer 3 things related to the interfaces. Okay, so let me open one switch, and for basic lab you can use dcloud.cisco.com. Because I haven't used this switch for last few minutes, so it is showing me that I'll not come up. Now it is up. This is one of the layer 2 switch. So show IP interface brief, you can check. It has some duplex and duplex mismatch because this is connected with the Nexus switch. I can check show IP interface brief to know what are the interfaces we have here. Because I am taking it remotely, so the commands are very slow. You can see here in the show IP interface brief, I have these three interfaces. Now suppose if I want to know the specific things about one interface, so I have to go and check that interface. The command is very simple, that is show interface gig00. So let me type that command, show interface gig00, and then we'll check all the parameters with that interface. This connection is really very slow, but I have other devices as well, so in the next class I will take those devices. Okay, so once the switch will come up, I will show you that command, and I think it is here. Okay, you can see here, show interface and then the interface name. So what are the things we have? So we can check the line protocol is up, it is connected. Its hardware is this, and this is the MAC address. This is something BIA, burnt int address. The MTU is 1500, bandwidth is this, delay is 10 microseconds, reliability, all these things. So what are the important things that we can check on this particular output, that we can check that this is up or down? Obviously you can verify the MAC address as well. Apart from that, you can check the input and output rate. If you have any layer 1 issue, and you will get that issue in upcoming future, you will get this overrun and CRC. If you get CRC and overrun, they are directly related to hardware. So CRC error generally we are getting when we have some optical fiber cable issues, and this overrun, it's very classical with the firewall type of thing, because the firewall, you know that firewalls are like single modular devices. So suppose I have 5510, it is single blade type of thing, right? You can think like a switch. It's like a switch, single. At that time, if you have so much traffic is going towards firewall, generally firewall is doing hardware switching, but because they don't have hardware resources, once the hardware resource will get overutilized, they will start software switching. So if the software switching will happen to any of the platform, you have the high CPU. So if you see this overrun and you have counters in the overruns, that means your hardware switching is not working properly. The packets are switched software, means they have the software switching, and at that time you have lots of you have high CPU as well. So CRC error and the overrun, you will get the cases related to this. Now if you have input errors, so we have some use cases for input errors, why the input error is there. I'll discuss this input error, and if we have something like unknown packet drops, those things also we can discuss in upcoming classes. But these type of things you can check. So basically you can check at the rate of layer 1 things, you can check at the rate of layer 2, and you have layer 3 information as well if you assign IP address here. So you'll get the IP addresses as well. Okay. Let me go back to our slide. So you can see what are the things, that link is flapping, link is coming up and it is going down. No POE, is this interface is POE? Do I have errors related to CRC or input errors or overruns or giant, all these things? What are the things you can do when you have such type of things? So in this particular platform, you can use the platform command, that is the show a platform software interface. Actually you have two commands, either you can use show platform software or you can use hardware. So not only this command, you have the hardware option as well. and this is some filters. Sometime data is working but PO issues. Then so I have one question here, and let us focus on that first. Okay, so question is that sometime the data forwarding is there. So switches are meant to do the data forwarding. So whatever there is the control plane doesn't matter. Sometimes the switches, they don't know even about the control plane. They are sending the frames. That's it. So issue is this, that your data channel is working. So suppose if you have some interfaces and those interfaces are in some VLAN or whatever, these interfaces are connected with PC and they are working fine, even they are connected with some other switches and they are working perfectly. But they are connected with some PoE devices like IP phones or something, and they are not working. So how to troubleshoot this PoE issue? I'll come in this particular section. Please do not worry. I'll show you that how to check the PoE issues as well. Okay. Just wait for 5 minutes. I'll come to that. So you can check all the basic things like speed duplex and isolate the bad hardware or the cabling issue, optical issue. So this is one of the classical alarm in 4500 that you will get cases like SFF8472. Someone is asking one question. So I'm coming to PoE. Please do not worry. After 3-4 slides, I'll come to that. So please hold on for 3-4 slides. So I am on the interface. I am here somewhere. Show interface and then the interface name. Now from here you can filter these things, but if you check show interface count errors in 4500, you'll get lots of information, and here you can see the control align error. So this yellow mark is showing that we have some error, and these errors, how we can map these errors. So you can map these errors with maybe some faulty cable or maybe faulty NIC, maybe some hardware issue. You have to just check out that how they are mapped. So I'm here on the interface issue. Just wait for 2-3 slides. You can check all these things, congestion and CRC and drops in the packets. You can check your TX and RX queue. For this particular pause frame, I will send you one link. I write something in my blog. So what is the pause frame and how it is used in 4500 platform. For that, I'll send you one link. You have these options that you can check, the counters and the drops options, and the same way you can check in the Nexus as well. But there you are using some command like show system internal, and then what are the drops there in the filter, pause bits. Now this is a specific with this particular line card. Let me go to the PoE. So please go through these slides. I am skipping some slides here for this. Nowadays we are getting lots of things, lots of cases related to PoE. And what is the architecture of PoE? You can see here that whenever you are using this access layer switch, at that time you may have two types of VLANs. So you have data VLAN and you have voice VLAN. So other VLAN is voice. Now your data plane or your data is working properly, but your voice VLAN has some problem due to some PoE issues. Now these PoE issues are very specific to a particular line card. Means in 6K they have different issues, in 4K they have different issues. So let us check this one by one. Now whenever you have PoE issue, how could you check that? Let me just pause the record. So when you are checking the PoE issue, the troubleshooting steps, so you can see on your over your screen, this situation may be caused by a device, that is using more inline power than the allocation. Please make sure that the right amount of inline power has been allocated to each device. If the inline power allocation is correct, start pulling out one device at the time. So this is the troubleshooting step, and this is really good troubleshooting step. So whenever you have issue with the inline power, means that means that some of the devices, suppose I have 4 devices connected with this switch. So some of the devices has pulled more power on this interface, and some of the devices are pulling less power. So that is one potential issue with this inline power. Obviously, you may have different cases with this inline power. In 3850, you have all the different story with PoE. So that's why they have releases something 3.6.5. That is the new release in 3850. But in terms of this 4500, 4500 is very specific with the line cards. So in this particular slide, you'll check that line cards, that which line card has how much of capability to provide the powers to all the PoE devices. So we will check that. But the basic idea is that these devices, they are taking power because once you connect these devices with these interfaces, they will wake up. And there are chances that these devices are taking more powers than the other devices. Means the classical example is Polycom. So Polycom devices, they are taking more power than the other normal switch, like say Avaya or maybe Cisco IP phones. So you have to identify that how much power budget you have per line card for these PoE devices, how much power they have already used, and how much is free. For that, you can use these commands. So show power detail, this is the topmost command that you can use. Show power inline, this is the second most important command that you can use. With the help of these two commands, you'll come to know that how much power you have in that particular line card and how much power that has been used. Now, one other thing here to know, that you have to understand about the line card as well. So it's not that simple that you run this command show environment status and power inline and you figure out that how much power they have used, because for all the line cards you have different power budget. So suppose if one of your customer in the same chassis, and again you have to check that 4510 is capable of 2 different line cards or not. Sometimes they are not. So you can't have 4648 along with 4748. So you have to check. So 4648 I have as one line card. Other line card is 46, suppose whatever 4548. So you have to check what is the overall capability of this particular line card and how much per port by default they are giving. So here you can see 3030, and this particular line card per port they are providing 12 watt. So you are capable of providing 20 watt, but what about the user? How much they can use and how much power, how much minimum power they need to run their services, or start their IP telephony services or other services. So you have to check both ways, not only with the perspective of the end device, you have to check the capability of the line card as well. Okay. Any doubt till this point you can ask. So it is started. Today I am going to cover high CPU inside 4500 box, and this is going to be one of the most important class that we have covered so far. The agenda is simple, the high CPU, and in this particular session I'm going to cover Cisco Live 3142. So this is the number, even you can also download, or even you can download from the Google Drive that I shared with a few of the engineers. This thing we have discussed yesterday, that how you can track the failure in terms of interfaces and failure in terms of PoE or data channel. So in terms of interfaces, what you can do, you can check the interfaces, means you can troubleshoot L1, L2, L3 things. So you can check the cables, you can check the L2 protocols, and you can check the L3 things, that is the IP address is assigned there or not. This was simple. So if you go through this particular document, you will come to know, yeah, what are the things I have to check on this particular interface. So you have to verify the error counters. So do we have any input error or overrun or giant or any CRC? So if those things will increase, suppose if CRC will increase, that means your cable is faulty or you have problem with respect to transceiver. That means you have issues with the hardware. So these things we have discussed yesterday. These things, apart from that, we have discussed what is the rough topology of this particular platform. So in this particular platform or any of the switch, interfaces are mapped with ASIC. Then you have CPU, you have forwarding engine. This forwarding engine is with respect to L2 and L3. And these forwarding engines, they have dedicated TCAMs and the CPU. So this TCAM has a big story that we have discussed so far. So this TCAM should be consumed by different resources like QoS, like ACL, like Netflow, IPv4, IPv6 traffics. Okay. So if you have any issues with related to TCAM, you can check all these services as well. Let me go to the next topic, that is the high CPU. Before that, in this particular presentation, you will get some very good troubleshooting steps related to PoE. So if you have PoE issue, what you have to check the hardware specification, you have to check how much power, that is the line card, is providing to the PoE devices, what is the maximum capability for that particular line card, is that particular line card is negotiating properly with the PoE devices or not. So these things you have to check, and these are the commands, these are the top commands to verify all these things. Now this PoE modules are plug and play, means once you connect the interface with the PoE device, automatically they give some power to the phones. This is automatic, but we have the option that we can statically assign the power to the interfaces where the PoE devices are connected. So if you want to assign that power statically, you can use this power inline, static, max, and whatever number according to your environment, you can use that. So please go through this document, and you will find very good information about all these things. So what are the top commands that we have to check in this particular case, or in this case? So top commands are these, and with the description. So whenever you have the PoE issues, you have to check these logs. So these are in terms of logs, and you have to check these debugs. So if you are not able to figure out what is the problem with these logs, you have to take debug, means you have to start the debugging, and you have to take logs with respect to that interface. Okay. So once you collect all this information, then it becomes easier to at least identify what is the issue, and then you can provide the solution. Now let me go to the next topic, that is the high CPU, and this is very, very important. Now we have a story with this particular high CPU. Story is with 2960 and 3750 switch, you have different steps to identify the high CPU. Now why we have different steps with these switches? Because these switches have very different architecture. They have very simple architecture, but they are very similar. We have different story with 3850 switch because its architecture is very different and it is using iOS XE. Likewise, 4500 also uses iOS XE, but the hardware, means the business unit of this particular switch, is different. So that's why its hardware is completely different than 3850. Although they are using the same train of iOS, that is the iOS XE, that is the Linux based code, but because their hardware is different, that's why the troubleshooting step is very different. So in case of 4500, the troubleshooting step is different, and likewise in case of 6500, the troubleshooting steps are different, and the Nexus 7K, it is different. Now on these bigger platform, you have very structured way to troubleshoot the high CPU. So what you have to do in this in these platforms, you have to follow certain steps. If you follow those certain steps, you will easily identify what causing the high CPU, and then you can provide the solution. So let me show you that how we can do that. This is the overall architecture for this platform. Now, troubleshooting with high CPU. So we have already discussed that the approach of troubleshooting. What is the approach of the troubleshooting? Either you can start from the top. So either you can start top, you can go bottom, or you can do in the reverse order. So in this case, whenever you're getting this troubleshooting alerts or messages, high CPU alerts or messages with respect to high CPU, the first command should be show process CPU sorted, and you can exclude 00. So this command is constant in all the platform. So you have to check your CPU. Once you identify in this particular CPU what are the other sub processes, maybe that high CPU is related with CPU, or it may be related to some flow through traffic. So it may be CPU based or it may be interrupt based. We have to identify that. So one by one, I will do all these things in this particular presentation. Okay. So here you can see in the notes fact that, okay, you have high CPU, then you have to gather the facts. So analyze the iOS XE process, the iOS process, what are the platform, what are the traffic, consider the possibility, out of system resource, DOS attack, software bug, and then this is the overall blueprint upon which you have to check the high CPU. So let me go to the command section. Now this is very important. This is really very important. So iOS. So we know that we are running iOS XE on this particular platform, that is the 4500. You have to understand that this high CPU is maybe due to the control packets or control protocol. So you can see here BPDU, CDP, VTP, PAGP, LSCP, DTP, UDLD. These are the control protocols with respect to, suppose most of the things are with respect to layer 2, and these protocols have their own dedicated MAC addresses. So for say for CDP, we have one MAC address. For BPDU, we have dedicated MAC address. For VTP, we have. For PAGP, LSCP, they are used in the Ether channel. DTP is dynamic trunking protocol, UDLD. So all these things we have some MAC addresses, and these are the control packets. So if any issue with these processes, you may have high CPU. Apart from that, process packets not supported in hardware. So in a particular switch, what happens that you have your soup engine, which is taking all the decision, and then you have the line card. So what happened when a packet start, if you have the program in the line card, it will be hardware switched. If the line card don't know how to reach to the destination, one packet will go to the supervisor engine, and then that program again it will be written down to the hardware level. So first packet should be software switched, and the subsequent packets are hardware switched. Okay, so you can say that you have two type of switching. You have hardware switching and you have process switching. So process switching or software switching packets, they are causing high CPU. That means if you are sending packet with TTL1, or if you are using something ACL log keyword, or you have something reverse path forwarding forwarding failure in case of multicast, if you have packet fragmentation, if you are taking CPU span source, if you have DHCP or IGMP snooping, if you have ICMP unreachables, all these things, all these packets, they are causing high CPU. So for all these, say AppleTalk or IPX, my switch is not capable to understand AppleTalk or IPX traffic. So obviously they will send to the supervisor engine for software switching. So the path will be via the supervisor engine. It is not via the hardware. That is, the packets or the frames are not hardware switched. So one by one, you can understand all these things. So what I'm going to do today, I will show you this ACL log, how if you enable the ACL log, your packets will be software switched. So if you send constant stream of packets and if those packets are software switched, you have the high CPU. Okay, so for all these things, it's very important to understand in terms of technology as well, that if you have unresolved ARP, if we have fragmentation, if we have ICMP unreachable, and this is very, very important. So say 2 out of 10 cases you will get like ICMP unreachable. So in a network you will find latency. Latency, why? Due to high CPU. So what you have to do, that is a Cisco recommendation, that whenever you are in the interface VLAN, something like 10, that is whenever you are under SVI, please enable no IP redirects, no IP ICMP unreachable. So no IP redirect, at least you do this thing, no IP redirects. Okay, so we'll see all the causes and why they are doing like this. The overall idea is this, that please do not send constant packet to the SUP engine or the software. That is the overall idea. Now let me go to the next slide, and now how you can identify that. So suppose in this case, now the CPU is very less, you can see 22%. This is the iOS XE process. Then this command is true with the 3850 as well. So when I'll start the high CPU with 3850, I will tell you that in 3850 switch we have fed process and we have iOS D process. In this case, in 4500, you can see you have the iOS D process, that is the iOS daemon, which is responsible to start all the other important processes. This is one diagram. So before moving further, I'll show you one very good document, and if you follow this particular document step by step, you will easily resolve 4500 high CPU cases. So in this also you can see that there are various control packets. So various control packets such as these packets, they are causing the high CPU. So there are so many other things as well that you have to keep in mind while you are troubleshooting with high CPU. So you know what are the control packets. Apart from that, you must know what is the architecture of your switch. So here there is some demarcation about 0, 1, 2, 3, 4 up to 15, and these are the queue. So in this particular 4500 switch, we have some reservation for different queue. You can see here simple management protocol is reserved for 0, like that. You have control, host learning. So all these things have some meaning. So Q1 is reserved for these layer 2 protocols. Queue number, so this is Q1, 2, 3. Q3 is reserved with these unknown source MAC addresses. This is related to ARP, maybe unresolved ARP. 345 is reserved for L3 forwarding low, medium. So here you will find some high and low terms in 4500. High is nothing but the higher management protocol, low is nothing but the lower management protocol. We'll see that in this particular PDF or notes. So these are the these are the queue reserved for different features, and these are the control packets that we have discussed in the Cisco Live document. Now, what you have to do to identify the high CPU, that you have to execute this command: show platform CPU packet stats all, and I'll come to this command. Before that, we'll again move further and check the things related to high CPU. Now you can see here this particular flowchart, and if you want the colored version of this, you can check this. So this is the same flowchart you have there as well. So now this flowchart, actually this is I don't find any much information in this flowchart. So what it is telling, if you have high CPU, you check show process CPU, and is it IOSD related? If it is yes, then you have to check Catalyst 4K low and high priority processes. If no, then open a tag case. Okay, then collect the show platform health. Now the thing is that what you have to do in case of 4500, first three commands are show process CPU, show platform health, and then show platform CPU packet stats. So this is the second one, this is the third one. Now what is the importance of all these three commands? With the help of all these three commands, you'll come to know what is the process or what is the interrupt that is causing the high CPU. So suppose, again, this is true for all the high CPU cases, that if you have high CPU due to process, so suppose this is one, you will get with these commands. If you have high CPU due to flow through traffic, then on that case you have to take packet capture. There is no other option that you can do anything. Now this packet capture may be external or it may be internal. So internal, the technical term of internal is embedded. So this packet capture may be embedded Wireshark, or it may be a span to some to some interface, destination interface. So this is the important thing. So process, if it is process, that means you have to stop the process to kill the CPU cycle. If it is flow through, means if it is originating from some other interface or some other VLAN or some other traffic, then you have to take capture. Okay, so I'll go next. These are the commands that is telling you here. That again, this particular presentation is like compressed version of this document. This document is actually very good with respect to high CPU 4500, and we'll come to know all these processes. So K2 is nothing but the core, for core, or you can tell the process or CPU. Actually this is the CPU of 4500. Management means MAN means management review. So we'll see that. I'll show you an output. See this particular output, so process CPU, you have different processes. So you have Catalyst 4K management high priority. This is for high management traffic, and this is for low management traffic. Now it's very important to understand that low management traffic triggers the high management traffic. Again, what does it mean by low priority? Low priority is nothing but you have programming. So in your programming you have low type of code, something like C or C++, and then you have some high programming code. We don't have Java here, but you can think like that. This is assembly language something, and this is C or C++. So low priority and high priority, and this is with respect to kernel. So whatever the kernel programming is there, this is entirely the management traffic. So it is managing all the process inside the 4K. this low priority and high priority. Now let me scroll down and I'll show you one of the very important thing here, that suppose if you want to check which particular process is causing high CPU. So in this case, if you, and again this is the second most important command in this platform, you can see here the list of processes. Now it's very easy to know all these processes with a short form. So suppose in this case I'm marking that okay, K2 CPU management is something 10%. A stub job event scheduler. If you know a little bit of programming, you know how the scheduler work. Now, apart from that, it's very easy. Suppose this is what K2 ACL CAM management. Like that, you can study all this, these processes. Say K2 L2, L2 with respect to layer 2 address management. So it is related to CAM. K2 ACL polisher, it is related to L2 policing, either ingress or egress. K2 CAM management, hardware statics. K2 CAM management is still. So why I'm telling you all these things, because this 4500 architecture is like a very independent type of architecture. Means you have different sub processes. These different sub processes like K2 L2 or K2 ACL or K2, you can take any example, suppose ACL management. So all these processes, actually all these sub processes, they are mapped first with K2 CPU high, and that is again mapped with K2 CPU low priority. So you have high priority and low priority. So this low priority is triggering the high priority, and this high priority is triggering all the functions, all the processes. So once you identify that, oh, suppose I am able to identify that, okay, K2 L2 is causing so much high CPU. That means what? That means we have issue with respect to L2 engine or with respect to L2 traffic. That means I may have STP issue, I may have CDP issue, I may have VTP issue, I may have any layer 2 control plane packet issue, maybe IGMP snooping. So all these things you have to check. Once you identify what is the sub process inside either high priority or low priority, they are mapped with K2. So K2 high priority or low priority has triggered the sub process like K2 L2 or K2 ACL CAM management, etc. So you have to figure out this with help of single small command, that is show platform health. Okay, let me again scroll down. So say it's very easy. You can go to any event and you can just K2 MET stat man. MET is multicast entry table. It's very much used in the replication ASIC that we studied actually in the Nexus platform, but that is true for all the platforms. So MET is maintaining the table for all the multicast traffic, for all the replications inside multicast. Even you can check anything like K2 QS DBL dynamic buffer limit, then K2 VLAN stat, K2 and bucket memory, K2 aging table, RKI iOS port management, module management, like that. So you can go through this particular thing and you'll find it that it's easy to understand, or it's easy to figure out which sub process is causing the trouble. Now in this particular example, you will find that they have given very good examples. So they have given example, say that if the packet is software switched, again remember high CPU is due to software switch or the hardware switch. So if constantly if the packet will hit the soup or it will go to the CPU, your CPU will be high. There are certain application or there are certain features, those are always going towards software. So this ACL with the lock keyword, If you have any loop, obviously if you have loop all the time, your all the time your software or CPU will be try to figure out what is the exact outcome of this. So till the point they are not able to find the exact solution, your CPU will be bitchy. The TCAM issue, host learning that is related to ARP, unresolved ARP, the other protocols that your supervisor or your line cards are not able to identify, ICMP redirects. So these are the top culprits of high CPU. Most of the time, 80% of time you will find your CPU cases are due to these things. And the snooping as well. So snooping, either snooping with respect to L2 or L3 or with respect to IPv4 or IPv6. Most of the time you will find that. Okay. Let me scroll down, and even here you can see the solution as well. You can use no IP unreachable. Actually, no IP redirect is the keyword. Okay. Now, in this particular notes, you will find there are different use cases. So in this particular case, you can see here that my CPU spike is due to Catalyst 4K management low priority, low programming engine, and again due to the spanning tree loop I have. And this is actually good that whenever you are running this particular command in any platform, so process CPU, it is telling that is it spanning tree, is it VTP, is it some other feature, is it CDP, is it some PIM, like that. So once you figure out at least that what is the process, then you can check specific things related to a spanning tree, that why a spanning tree is not stable, why there are so much BPDUs are going across. So you can limit those things, you can reconsider your design once you figure out about your spanning tree loops or maybe L2 loops. Then you have to check the show platform health, and then the third command is show platform CPU packet. So 3 commands. If you want to figure out the Catalyst 4500 high CPU, you have to check show process CPU, that is the first. You have to check show platform health, the second one, and third one show platform CPU packet stats. These 3 commands, when you will do these 3 commands, you'll come to know what is the process, or is it the flow through or interrupt traffic. After that you can use the solution. So let me show you something, and these are all things related to either Apple talk or ACL logs or all these things. Issue related to host learning. So what will happen if we have the host learning issue? Still you have to learn, still you have to apply or execute 3 commands, process CPU, platform health, and this show platform CPU packet stats. But this is the way that you can identify the problem. Then what we can do for the solution? So for solution, if you have STP loop, you have to check your STP loop. If you are using ACL log keyword, then you have to remove ACL log keyword. If you are using non-IP traffic like Apple talk or maybe some other traffic like novel or whatever traffic, then you have to check those traffic, or you have to limit those traffic inside the control plane. Okay, so till here everything is okay. Now the other step that you have to follow, that how you can do the packet capture in case of 4500. So let me recap that thing. So I already told you that either the packet will go via software or it will go via hardware. So if you are able to identify that is ACL log is there, or any unresolved ARP is there, or anything, IGMP snooping, whatever, all the 20 things. If you identify the thing, in this case what you can do, you can remove the ACL log, you can disable IGMP snooping and then again enable it. You can check why the ARP is unresolved, etc. That all are related to CPU. But suppose everything is okay, still you have high CPU, means that high CPU is due to traffic. Then what you will do? Then you have to check the root cause for the traffic. For that you have to take packet capture. Again, this packet capture, actually I have one complete class for packet capture for all the platform. So either it is ASA firewall or ASR routers or Nexus or switch or anything. So I will take that very soon in coming 3-4 days. But packet capture, either it is external. So externally you can mirror the frames and you can send somewhere. So you have source somewhere, you have destination somewhere. So what you are doing actually, that you are mirroring the frames and you are sending somewhere. The other one is the same. Again, the packet capture is packet capture, that is embedded. In some of the platform, you have embedded packet capture feature, like in 4500 in I think 3.6.x, and the newer code you have this feature with 7LE or 7L, SUPS 7L and afterwards. Maybe in SUP 6 as well you have this feature, but I'm not sure. 3850, 36 and X code, you can do the embedded Wireshark. In these two platforms you can do embedded Wireshark. In Catalyst 4500 we have other options as well. Okay, so we'll check the other options as well. From there also you can figure out that from where this flow through traffic is coming. So let me show you the packet capture things as well in this particular note. So you are running only those 3 commands, you are figuring out what is the issue. Now how you can create this span. So it's very easy to create the span, and in this case the span command is related to CPU queue, all receiving packet, and say you have to define the source and you have to define a destination. In this destination you have one PC with Wireshark installed and you can take the captures. So it's very easy. And while I'm here in this example, you can see that what are the option you have. So even after source you have option for interfaces, VLAN, like that. After CPU you have these options. After CPU queue you have all these options, means you can gather the packets related to bridge traffic, control packets, MTU exceeded, Netflow traffic routed, RPF failure span. So all these things are the culprit, all these are the control packets actually. You can gather information. And how you can verify? Actually you can save these things somewhere in the flash and you can we are sending this here, so obviously if you have Wireshark on, you can open Wireshark and you can check, you can save this file and you can take it as a reference. Now the other very important capturing tool here for 4500 is this. So debug platform packet all received buffer. The only limitation with this particular option that they can retain only this much of packet, 1K packet. So whatever next packet will come, they will rewrite those packets. So that is only limitation, and we can't increase the buffer size for this. Okay, so at least you'll come to know who is the top talker at that time when you are doing the live troubleshooting. And this hex value you can easily convert to the pcap file and you can check it. So whenever you have such type of hex code, there are applications where you can convert txt to pcap. So if you convert txt to pcap, you can check inside Wireshark. You can import that packet inside Wireshark and you can check it. Okay. Apart from that, you can see here what is the important thing. So yeah, so this MAC address I want to show you. These MAC addresses are specific system generated, or maybe you can tell the control packet generated MAC addresses. So these type of MAC addresses you will see with CDP or VTP or other protocols. So these are specific multicast MAC addresses reserved for some control packets. Okay. This way you can gather the information and you can do the troubleshooting. Apart from that, again, these 2 commands are really very important, but still what you have to do, you have to understand what is the process causing the high CPU, what is the flow through traffic, or what are the traffics who are causing the high CPU. If CPU or the process is causing the high CPU, at that time you can turn off the process, means you can bounce that process, So you can bounce the IGMP snooping, you can bounce the other process, but if it is due to traffic, so at that time you have to take the span, you have to take the capture. I'm going to stop here for 5 minutes and then now I'm going to show you how you can figure out inside a switch. Although I don't have 4500 switch, but I have layer 2 switch, and how you can send packet via software switch or with respect to hardware switch. That lab I am going to show you. Apart from that, I'm going to show you that how the ARP learning happens inside a switch. So I have a fairly simple topology. In that particular topology, I have 3 switches. They are connected like this, maybe like this. I have 2 PC, PC1 and PC2. Now, all are by default, all the interfaces are in VLAN 1. So all the member interfaces are part of VLAN 1. Even these interfaces are also part of VLAN 1. Now, because I don't have PC, I took router, and I'll make router as a PC. In this particular router, I have IP something 10.1.1.4. Here I have IP 10.1.1.5. So I haven't pinged from 4 to 5. So once I will ping from 4 to 5, how the switches will learn the MAC address of router 2, router 1 or PC1, PC2, that will figure out with the basic MAC show commands that I'll show you. That is the one thing. Second thing I want to tell you about these switches, that suppose this is your switch. The thing is how switch learns the MAC address. So what happens when suppose this PC and this PC, suppose take a case of only 2 PCs are there, PC1 and PC2 with IP something .1 and it has IP .2. How this particular PC will learn the MAC address, or how the ARP process and the ping process will happen. So what will happen if you ping from PC1 to something like 10.1.1.2? This ARP request will come here, and then this switch will learn the MAC address of this PC. Suppose this is AAA. It will install that particular MAC address in the switch CAM table, and in the CAM table we know that what are the segments of the CAM table are. So what is the interface name, what is the MAC address, what is the VLAN, what is the aging time. It will learn in the CAM table, and because this particular switch don't know what is the destination MAC, that means the switch will forward to all the interfaces, because the destination for that particular frame or packet is all F. So switch will broadcast that frame. So ultimately that packet should be ARP broadcast. Now this PC2 will receive the ARP broadcast from the switch, and because it knows that, oh, this particular IP is with me, means the destination IP is .2 in that particular field, so it will tell the switch, oh, this particular frame ARP broadcast is for me, so please take my ARP unicast with the exact destination MAC address. Now this switch will install the MAC address of the destination PC. Suppose this is BBB. Now switch knows what is the source MAC and what is the destination MAC, and then if the next packet will come, it will not get broadcasted that, but rather it will go here. So once the ARP process is done successfully, then your ICMP process will start. So then you can see your ICMP echo and echo reply. Means you are sending the echoes, you are getting the reply, that is one ping, that is packet internet grouper. So request will go, reply will come. Now when we are doing the troubleshooting with respect to switches or with respect to PCs, we have to check that the particular MAC address is installed in the CAM table or not. Is there any instability in the MAC table? Is those MAC addresses are aging out frequently? So sometimes you have loop due to this as well. Sometimes you will find that you have layer 2 loop in your network. Why? Because your CAM table is, you know, is filled out within 1 second or 2 seconds. So within a second your CAM table is populated and it will start broadcast all the frames to all the interfaces. So it is vice versa. So maybe if you have loop, then your CAM will fill out. If your CAM is filling due to iOS bug, then you have loop. So it's vice versa. But 80% of time you have loop and then your CAM will fill out. 20% of time you have some bug, something is some problem with the code, and then you have loop because your CAM is unstable. So if your CAM table is unstable, means you have loop. So this thing will check out in the lab. So I have lab devices. I'll show you that. And in that particular lab, at the moment everything is blank. So this is the topology. What I'm going to do in this particular thing lab, that here I will assign some IP.4, here I'll assign IP.5, and I'll make this router to behave like a PC. So I will turn off the routing engine inside these routers, and then I will ping from 4 to 5, and then we'll check that how the switches are learning the MAC address and how the ping process happens. Once we'll understand all those steps, after that I will create one ACL inside this switch, and then I will simulate the high CPU inside the switch. So this is the overall lab that I'm going to show you here. Now I'm going to show you this here in the super putty. So I have devices. Let me show you the diagram as well. So let me compress this bit so you can check both the topology and the. This is my topology. These are the devices. And for this simulation, I am using Cisco IOU. So Cisco IOU is lightweight application, and it is very much similar to GNS. Actually, this is inside GNS, but this is some different program to simulate the router and switches, and you can take as many router or switches without any issue. I'm going to configure this interface. You can see the interface is E00. So if I am on this interface, no problem. But if I type something like IP address and then 10.1.1. suppose 4, if I press enter, I will get error. You can see why I am getting error, because by default this interface is in layer 2 mode, that is switch port mode. So I have to type no switch port, and then I have to assign the IP address. Means I turn this port as a layer 3 port. Then obviously I have to do no shutdown on this interface. I can check this interface with show IP interface brief exclude unassigned. So this is the IP here. If I check show IP route, because potentially this is a router and I want to disable the routing table or routing capability inside this router, then I have to type no IP routing. And then if I check show IP route, you can see here that the routing has been disabled. I'm not going to use any default gateway here because all these devices are in same VLAN, that is VLAN 1, and in VLAN 1 we don't need any gateway for the moment for this particular lab. Now the same thing I'm going to do on router number 5 or IOU 5. So no IP routing, then interface E00, then no switch port. IP address is something 10.1.1.5 with subnet of 24. That's it. Okay, now these interfaces you can see here on the switch side. So switch side interfaces are still on shutdown mode. So what I'm going to do, that I'll go to all the switches and I'll take a range of something like 00 to, so I'll do one thing, I'll configure all the switches in the single shot. You can see here in the command by the bottom of this super putty. So once if I type this command on this command prompt, it will write to all the devices. So all the devices is in the global configuration mode. I am going to take a range. So the range is something like interface range E0/0 to something 3 no shut. So this is executed on all the switches. That's okay for me. I don't want to take routers, but my purpose is solved. So I have the IP addresses on the IOU 4 and 5. Now if you check the CAM table of this particular switch, that is the next to router number 4, that is IOU number 1. So let me go to that. Show MAC address table. This is the CAM table. Now this CAM table is empty. You can see here what are the segment of this CAM table, content access memory table. Segments are which VLAN the CAM is associated with, what is the type, is it a static or it is dynamic or it is third party. What are the ports involved, what are the aging time, you will come to know about aging time as well. So these are the building blocks of the CAM table. If I type some other options with the CAM table, let us see the other options as well with this CAM table. Show MAC address table, and if I type count, why I use this, so it is telling that total number of MAC address this particular platform will hold this much. So suppose what will happen if we cross this limit. If you are crossing this limit, that means you have layer 2 loop, means your switch is busy to learn new MAC addresses frequently. So in this particular CAM table, it's very important to understand that whenever a switch learn a MAC address, it will hold that MAC address for 600 seconds, that is equivalent to 5 minutes. Obviously you can change this time as well. So suppose you are learning one MAC address for 5 minutes. If none of the activities happen with respect to that particular MAC address till 5 minutes, that means that MAC address will be age out, means the switch will delete that entry or flush the entry from the MAC table. Okay, so these things you have to these are the basic things of the CAM table. Let me go back and enable debug on the router or maybe switch. So I am here on 4. I can enable the debug. Exit. I will enable something like if I enable debug here, then I'm not able to see some outputs, but no worry. Debug IP ICMP, debug ARP as well. I want debug ARP. We can check how many debugs we have. Show debug. So ARP and ICMP has been are there. Now what I'm going to do, I'm going to ping 1.1.1.5 for one packet. Now you can see here there is nothing on the CAM table. Oh, they have learned. Maybe I have started the ping, but no worries. Do one thing. I'll do one thing here. I'll clear the CAM table. Clear ARP cache for all. Show MAC address. And these commands, please do not run. Clear ARP cache. Yeah, if you are very specific for which particular IP you are clearing the ARP, or for which particular interface or VRF you are clearing, you clear for that. But please do not run this command as like clear ARP. It's like clearing everything from your CAM table. Okay, no problem. It's already there in its CAM because I enable the debug. But anyways, if you send the packet, what will happen? Now this is the inherent property of the routers, that routers, they are doing the gratuitous ARP. So suppose I haven't sent any packet from routers to switch, still the switch is learning the CAM table of this router because they are using something called gratuitous ARP. or sometimes it is called as Arp Redirect. That is the feature inside iOS. That is inbuilt feature of iOS. So all the time they are sending some packets to the switch. So that's why the switch is learning the MAC address. But if you connect a PC, if you don't send any packet, it will not learn the MAC address of the PC. And after 5 minutes, it will age out that particular MAC entry. But in case of when you are attaching the routers, that is iOS routers, the switch will learn the MAC address for that particular interface. Okay, so here you can see here in the debug what is the important in this particular debug packet. I have enabled the debug. So before doing the ping process, they are doing the ARP process. So source, he don't know what is the destination MAC address, so they are sending some broadcast packet. Switch is actually forwarding the broadcast packet to all the interfaces, even in this interface. Now he is getting that particular broadcast frame and sending to the PC 5 or router 5, and in the return packet, that is the ARP unicast packet that we have discussed. So now because they have the MAC address, you can see here on the PC number 4, he knows the MAC address. What is the MAC address? 0500. So if I am here on the IU5, if I type show interface E0/0, you can see here, this is the MAC address. This is the router 5 MAC address that is learned via router 4, and vice versa, router 5 will learn the MAC address of the router 4. So if I do show ARP, it's okay, but this particular switch, that is switch number 3, show MAC address and the table. So it's a bit slow switch. You can see here in this particular switch, even you can see on the other switch as well. So wait for some time. Now it is learning the MAC address of the router 4 and 5 as well. Okay, so this is again one important process. Now what I'm going to do here, I'm going to create one access list on switch number 1, because I know what is the source and what is the destination, to show you how to simulate high CPU with respect to ACL log. So I can create one IP access list extended. Now the devices are a bit slow. So you have option, either you can create extended ACL or the standard ACL. In this example, I'm creating one access list that is extended, something high CPU. Now what I am permitting, I am permitting any IP traffic. So permit IP any, and with the destination off. So I'm going to assign one IP address on switch number 1, something 10.1.1.1, and then permit IP any. So if I ping to switch number 1, that will hit this particular access list. I'll show you both the things. Show IP access list here. I have entry number 10 with this statement, entry number 20 with this statement. At the moment, I haven't added keyword that is log. So I'll wait for some time. Once I will do this thing without log keyword. So if you will not add the log keyword, that will be hardware switched. If you add the log keyword, that will be software switched. Let me go to the in the same switch. Let me go to VLAN number 1, and in this particular VLAN, I'm going to assign one IP address because all the interfaces are in VLAN 1. So the IP address is something 10.1.1.1 with 255.255.255.0, and let me ping from 4 to 1. So ping 10.1.1.1. So it will take some time to do the ARP resolution. Once the ARP resolution will happen, after that it will start pinging. So you can see here one packet reaches there, and now I am not covering a spanning tree class in this particular session, but yeah, you can check the spanning tree with respect to VLAN 1 and what are the ports are in the forwarding state. So I'm not going to cover the root port, designated port and block port for the moment, but you can see all the ports are in the forwarding state, and it's okay. So we are capable to ping from here to the switch. Yeah, you are getting one ping drop due to some latency issue inside this GNS box, but it's okay. Yeah, the 3 pings we have, because this is directly connected device, so no worry on that part. Let me check show IP access list. So I use that access list, but I haven't applied anywhere. Let me go to interface VLAN 1 and I can apply this access list like IP access group. The name is high CPU in the ingress direction, and let me check what entry it is hitting. Oh, not that. So again, I'm going to ping from router number, sorry, what I have done. Oh, sorry for that. I have to create this access list on IOE1. Yeah, sorry for that. I have to create here, so no problem. I'll copy and paste inside VLAN 1. VLAN 1. I'm sending traffic from 4 to 1. So interface VLAN 1. Okay. Okay, now it's okay. So let me go to interface VLAN 1 and we can delete this. Everything is okay. I'm going to ping from this switch to my switch number 1, and let me check the show access list. Okay, so you can see here we have matches here, means we have hits here. That's correct. The configuration of ACL is correct. Now we can check show process CPU sorted exclude 0.00. We have 0% CPU spike, and let me create one alias for that. So I can create alias exact HC for high CPU. So for this I have created one alias. What does it mean? If I type HC, it will execute that command. If I type HC, it will run that command. That is the alias for that. Let me enlarge the screen. HC will show you that. So at the moment we don't have any CPU spike, and why I am checking here. So this is the sender, there is no high CPU, and this is the receiver. So create, let me create one alias here as well. Alias exact, suppose HC, and then paste it. Okay, so if I do HC, that is high CPU, you can use any name. no problem. So it is showing. At the moment we have some high CPU here. It's okay, 19%. It's not that much high. Okay, and so IP access list. Let me check the access list. 10 matches. HC 17 and 19%. Now what I'm going to do, that I'm going to edit this particular statement and I'm going to add one keyword there, that is the log keyword. So IP access list extended is high CPU, and I can give one name here. So actually you can, if you want to edit access list, you can give the number 9. So 9 will come above 10 and you can edit. You can use the same and then use the log keyword. If you check do show IP access list, now 10 is above 9, so obviously they are reading this access list top to bottom, so this will be hit instead of this line. If you want, you can delete the 10 as well. Access list. So now I have entry 9 and 20 and everything is perfectly fine. Now what I'm going to do, I'm going to check the high CPU with the log keyword, and I'm going to generate lots of traffic to the core. So if you want to generate lots of traffic, what you can do, you can ping to the destination. If you want, you can define the source. If you don't want, please do not define. And the repeat count is something like very big. And if you use one keyword, that is timeout, if you use this keyword timeout, that means they will send the packet at a line rate. And that's it. Enter. Now the switch is hanging because you will come to know that your CPU spike will come into the picture. So I am doing only HC and it will come up in couple of seconds. Let me re-verify that is it hitting my log keyword or not. So for that I can check show IP access list. Show IP access list, and the switch become very slow. And I am typing, after 1 minute things are coming. So I have already entered here. It is taking some, yeah. So it is hitting the log keyword. That means the packet is going via the software switch. They are not the hardware switch. And if I check the increment, so they are incrementing. That means if I check my high CPU, that is the HC, alias for high CPU, it is not showing that much, but it will come up. I can do another modification as well. So yeah, it's okay. I can increase the size as well. So this is a way that you can simulate the high CPU case in your lab, because we are using all the virtual machines, so maybe it will not come up like that, but these are the functions that Ethernet MACsec or maybe MSec, TI and IP input. These are the things you will find. You can see 42% and 14%. You'll add, it will grow up like 50% or 55%, like that. So you can simulate this thing here. Let me pause the recording, and if you have any. Hi everyone. So I'm going to cover 4500 troubleshooting steps, and I'm covering Cisco Live 3142 presentation. We have already discussed up to how we are doing the high CPU testing or high CPU troubleshooting for this particular platform. Today I will show you the licenses, and I will skip this QoS I will hit license, Netflow, and bit of Wireshark. Okay. Why I will skip this QoS? Because for QoS we need 25 to 26 classes. This QoS is huge, and this is actually different for all the platform. For 2K it is different, 3K it is different, 4K, 6K Nexus. Even routers, they are different. So we need something like very deep knowledge inside QoS to understand QoS. Okay, so let me start with the licenses first. Now for license, I already shared one document, one PPT with all you guys, but in common term, we have three type of license in the switch platform. You can see here inside universal image, we have LAN base, IP base, and enterprise services. Sometimes there are chances that sometimes you'll get cases related to licenses. For that also I have one PPT. I prepared it long back. You can see here. This is not related to architecture actually. This is related to the licensing for switching platform. So what are the features you have in the LAN base? So LAN base is nothing but you will get L2 type of features. You have L3 routing capability, but that will be very limited. Then you have IP base. You can use this IP base. You have all the features related to routing, switching, and other functions. But they have, Cisco has removed some very advanced features related to multicast, or you can see WCCP and policy-based routing and VRF Lite, all these things. So you have all the features in IP base. You have all the features. In IP services, you'll get all feature including these features. So please go through this slide. You'll come to know that what are the things there are in the IP services, those are not in the IP base. That means that IP services is full-fledged license. So once you run IP services license, you have all the features. Now, sometimes what happens that whenever we RMA a switch or a router, at that time by mistake customers initially they are running some IP services, and next time they have this IP based license and they are thinking, oh, some of my services is not working in this, although I am running all the commands, but still routing is not working properly, or some sort of load balancing is not working, some multicast is not working. So you have to check this licenses as well, that whenever you RMA, please be 100% sure that initially what license level they have, now what licenses they have. Because by default, Cisco is sending, I think, IP base license to all the customers. So if they have the 15 dot something 333, some latest image code, still that particular license will not support all the features. So be careful on that. Now, how could we check the licenses? In terms of ASA firewall as well, you have different license. So you have base license and you have enterprise license. Base license, that it has very limited capabilities, that you can't have virtual contacts inside ASA firewall. You can't do active failover inside ASA firewall, but in the enterprise level you have all those features. Plus in base license you can't have all the MQC inspect engines inside the ASA firewall that you have in the enterprise level. So there are differences in the base license and the enterprise license in actually in all the platforms, not only in the switches, but you have in the uh, firewall modules or the security modules as well. So how could you check the licenses inside the device? And actually for this I have already sent one PPT to you guys, that from where you can download the pack, what is the use of UDI. Actually this UDI number is the main universal identifier, and you have to download that image from that site that I have shared. I think www.cisco/go/license or something. You have to use that. Okay. Now these commands are very useful. So show license all, show license in use, and you can run these commands on all the platform. So either it is a 3K, 4K, 6K, you can run. Now if you want to install A license, what you have to do, that license file that you get from the Cisco, you copy that file into the boot flash, and from boot flash, with the help of this command, you can install it. So license install boot flash and the license name, because this is the license name inside the boot flash. After that, you can check this. So I got one case related to VSS. One of my customer, what they have done, they have replaced the supervisor engine, and after that they are not able to run or execute the VSS commands on the box. So when I checked, I found that they are not running the enterprise level license inside that box, although they have installed the license. But after installing the license itself, you have to run this command, that is the license boot level is enterprise level. So if you check show version, the show version will tell you that at the moment I am running something like IP base. If you set this variable and if you reboot that, then it will give you a message that after first reboot or reload, the license will change to enterprise services. So once the license will change to enterprise services, then you can run the VSS application or feature on the box. So be very careful about this licensing term. Although it's a very small unit, but yeah, sometimes if some features are not working, you have to check the license. Okay, now coming to this big topic, that is the QoS, and I will skip this QoS because in this presentation also you will get very less information about QoS. QoS is a big topic because for software and for hardware you have different type of QoS, and these architecture of because the architecture of switches are different, so that's why the QoS is different for all the platform. So you will find that, yeah, let me use the red color. So for 2960 and 3750, you will find the hardware QoS is very actually easy. In the first time you will find it a bit difficult, but once you understand, you will find it easy. So you have, suppose in the hardware level you have Q1, Q2, Q3, Q4, where you can program the QoS things on the line card itself. So you have some commands like MLS and then QoS and then the rate limit, like for Q1, Q2, Q3, Q4. By default in these platform you have QSet1 and QSet2, and generally we are using QSet1 for all the hardware programming inside the 2960 and 3750. Now this 3850, so some of the customer, they have migrated from 3750 to 3850. So what they want, suppose they want the same QoS feature they have in the 3750 to run in the 3850. Now the 3750 is using iOS, 3850 is using iOS XE, and this iOS XE, that is the good question, I'll come to that. And this iOS XE is using something like MQC type of thing, or yeah, you can tell that modular QoS CLI this iOS XE is using. So that's why it's very different to migrate iOS from say QoS policy from 3750 to QoS policy inside 3850, because both the hardware, both the softwares are different. So there are some design guide, there are some documents that you can follow and you can migrate line by line. Now the 4500, again, it's very different. It's really very different, and their hardware programming is very different than the other module like 3750 or 3850. Okay. Likewise, suppose if you are running 3500E series and you want to migrate to 6800X series or maybe 6904, at that time again it's a bit tricky, because these new supervisor engine 2T engines, their QoS programming is very different than the normal 6500 QoS. So the hardware is different, so that's why the QoS is different. Now the basic principle is same, that you can use policing You can use marking. So let me start with this. You can use marking and classification in terms of toss or COS, that is the layer 2 marking and layer 3 marking. Apart from that, you can use the policing and you can use the shaping. You can use the queuing. So either it is low latency queue or whatever, either it is priority queue, low latency queue, or class based weighted fair queue. So in all the QoS you have these features. You can classify, you can mark, you can polish, you can shape, you can queue, or you can prioritize the traffic with help of RAID or weighted random early detection. So you have these 4 features everywhere. Now these 4 features are generally software based features, and Imran asked that in router the QoS same. Generally in the routers, these routers, like not the ASR routers but the normal routers like 2800 or 1800 series routers or maybe 2900 series routers, these ISR routers, they don't have forwarding line card engine. What does it means? If you see a particular switch, a switch is something like this. They have central brain, that is a supervisor engine, and then they have line cards. So in their line cards, again they have chip, they have buffer memory and some processing cycles, plus they have TCAM for QoS. This is not there in the router. So that is the reason routers, they are doing software based QoS. And the software based QoS, that is generally you will do in the ingress direction. So ingress direction, they have the software based QoS, but in the egress direction, whatever there in the line card, whatever come first, they will send. Means the egress direction, they are using first in first out, that is the FIFO. So you can program the receiving queue, that is the RX, but you can't do much on the outgoing direction. So better I'll write like this. In the ingress direction you can apply the QoS, but in the egress direction it will use first in first out. That thing you can change on the switching platform. So in the egress direction as well you can do some QoS. That is not there in the routers. So that is the difference. The QoS strategy will be same, that you will get at least you will get classification or and marking. You will get policing and shaping. Here you have the marking. You will get the queue, that is the queuing, and you have some other methods like weighted random early detection or some compression methodology. Okay. So we'll come to that QoS part in advanced networking classes, but for the moment we can just skip it. For this particular, to troubleshoot this 4500 QoS, you please go through this. In this particular PPT you will find that they have given certain cases where you will get QoS related issue. So what QoS is doing here in this particular presentation, that QoS is directly proportional. We know that QoS is directly proportional to TCAM. Even other functions like Netflow is also directly proportional to this. IPv4, IPv6, all the time I'm writing this because you remember this. And then the ACL. These things are directly proportional with the TCAM. So if you will not use QoS wisely, they will exhaust your TCAM memory, and then you will get certain errors that packet drops in the egress direction, or your services will unstable, even you have high CPU, and the other undesired things happen in your network. So if you want to check, you can check with this show platform. Now it's very important to understand in this particular platform, that is the 4500, you have 2 very important commands to start with. That is the show platform hardware, show platform software. Okay, and then if you type question mark, you have the other options. So what it is telling, that TCAM has been exhausted. Why? Because 100% of the TCAM has been utilized for QoS, and then you are getting such type of message in the syslog that the hardware ACL management, ACL hardware program error, hardware TCAM limit QoS being disabled on the relevant interfaces. So automatically QoS will disable. So if you get this message, that means your TCAM has been exhausted. Then you have to reduce the number of lines or the number of entries inside the QoS policy. So suppose if you are using more number of lines, more number of ACL lines inside QoS, you have to reduce that. So let me show you one example about this QoS, that whenever you are doing this QoS things, at least software based QoS programming in the modular QoS framework or modular QoS CLI something, at that time what you have to do, first you are defining the class. So whatever class name XYZ, in this class you can call ACL or you can call any type of protocol. So once your this container is filled, that is the class name, then you are creating something called policy map. This policy map, suppose again XYZ, in this policy map you are calling the class, suppose XYZ. Once you are under policy map, under class map, then you can use other functions, that you can use policy, you can use shaping, you can use any queuing method. Okay, so step number 1 to define the class, step number 2 is to call that class inside the policy map, and the step number 3 is obviously you have to apply that into certain interface. So you can go to the interface and you can apply like service policy and then the policy name, whatever policy name is, and then either in the ingress direction or the egress direction. So either in or out, you can apply that. So this is 1 to 3 step of this policy map, this QoS. But behind the scene, you have to do lots of other optimization, lots of other study, that how it will work inside software, how it will work inside the line card or the hardware, and then you can utilize all these QoS entries. Okay, let me go to the, so you please go through this, all these things, and then you have some memory related commands that you can check that. Now these are the top commands that if you have any QoS related issue, so you can check all these things. So what is the ACL statics, what is the QoS policy, utilization, how much hardware has been allocated in the transmit direction, and these things. Yeah. Okay, let me start this flexible Netflow. Before starting that, I'll wait for 2-3 minutes. So the next topic is Netflow, and you can see here the flexible Netflow. So Cisco has done lots of enhancement in Netflow, network flow, and why they have done lots of enhancement in Netflow? Because these are the services that is used for commercial purposes. So suppose I am a non-IT engineer or non-networking engineer, I don't know about networking, but what I am interested of that how much CPU utilization is for this particular router, how much link utilization, what is the uptime, what is the downtime, what is the memory usage, all these things you can get from the Netflow. So that's why it's very important. Even you know this SNMP as well. SNMP is also a management protocol. But with the help of Netflow, you can export or you can import certain records. So what types of record you can export or import? Actually, this has 7 different field. Let me go to the next slide. FNF, flexible Netflow, you can see here. So, okay, forget this soup engines, but what you can do here in this Netflow, and I will show you the example as well in today's class, that you can create this with respect to source IP, destination IP, source port number, so suppose SP, that is source port, destination port address, that is your DP, protocol type, that is suppose application, toss bit, this is again directly related with QoS type of service. This is 8-bit field inside the IPv4 header. So if you check the IPv4 header, you will find that 8-bit column here, toss. that is for type of service. Input interface plus the interface. So input interface, you can see 1, 2, 3, 4, 5, 6, 7. So you have 7 different fields while you are configuring the net flow. A flow is user defined with flexible net flow. Flexible net flow supports L2, IPv4, IPv6 fields, and we have two variants of this net flow. Yeah, that is again good question. So see, Imran has asked what is the difference between the normal net flow and the flexible net flow. Now the difference is that you have enhanced feature. So you have enhanced feature that is supporting IPv6, that is supporting other features as well that we can see in the lab. Okay, they have this V9 as well. So one of the most important thing here in the advanced feature, that is the flexible net flow, is that flow is user defined with net flow. That means you can define the flow record. So I will show you how you can build the net flow, but yeah, you can build a record. So actually there are three main constraints of this net flow, that you have record, and this is user defined. So that is the main difference. So per user, suppose you have different departments. Suppose you have IT department, you have finance department, you have HR department, you have other departments as well. So you can define record for them. So per users, like record IT, record HR, like that. The other main thing here that we'll see, that we have actually monitor and we have exporter. So we have three important field: record, exporter, and then the monitor. And we can see that how inside the monitor, so how this function is working. Inside the monitor you can call first and second function, that is the record, that is the flow record actually, and the exporter. So the main difference behind the normal and the advanced NetFlow is that you can define the user record in this, and they have some enhanced features. So you can get records with some other functions like IPv6 and some other L2 new features. Okay, I'll show you all these things in the example, that how you can call the function and how you can check the function. So no problem on that part. In this particular NetFlow, you can add EEM script as well. And once I'll show you that lab, I'll show you the how you can verify that. Now this is a good slide here where you can check the NetFlow fields. So destination IP, source IP, protocol, precedence, DSCP, TOS, all these things you can monitor with respect to IPv4 and IPv6. These are the commands that actually we can use. Once you apply NetFlow, you can track NetFlow with these commands. So let me show you on the lab this thing, and then we'll go further. Okay, so I have one device here in my other system. Let me open that. So I installed that GNS, and inside GNS I have this router. Let me open this router R1. Let me increase the font size for this router. You will get NetFlow cases, and the thing is that what you have to check, obviously you know the configuration. The thing is that in some iOS the NetFlow configuration is different than the other iOS. So the customer, suppose they are migrating from one hardware to other hardware. Yeah, sure, I will explain that, please do not worry. So your customer, they are upgrading the switch. Suppose they from 3K they are moving to 4K, So 3K and 4K commands are different. Even in the 4K, suppose they are moving from 45006 to 4500X. In that also the commands are different. So you have to check the reference guide. Suppose someone is moving from here to 4500X, the commands are a bit different. So sometimes the flow record is supporting, sometimes is not. So you have to check the reference guide for that. But yeah, this Netflow configuration and troubleshooting is easy. 50% of time you will get error with related to TCAM, that how this Netflow is causing the TCAM exhaustion, and the rest of the time you will get issues like with once the customer has started Netflow, their routers or switches get crashed. Other time you will get issues like they are using Netflow, and due to that Netflow they have high CPU. So at least 3 type of things you will get. Actually we can do the fourth one, that is the configuration related. So how they have done the configuration, then the high CPU due to this, then the TCAM exhaustion, then the crash due to Netflow. Even you have bug related to this and this as well, even for this as well in certain platforms. Okay, so let me configure base type of Netflow in this router. I'm here in this router. Is this router is, yeah, this is paused. Start. Okay, so I have started router number 1, and then I can do the Netflow configuration. So what you have to do, we have 3 things. First you have to define the record. So you can use flow, and you can type question mark here, which is asking for name. See, in this router the command is bit different. I have done in the switch. Yeah, in this router the command is different. So no problem. Flow. I'll show you in the switch as well after some time. I don't have this option of flow, record and sample. Let me check. I must have commands related to this. Yep. I'll show you the commands. In this router the switch commands are not supported, but please do not worry, I'll show you that. It will take hardly 2 minutes. Once I install the GNS in the IOU mode, you can see here what you can do. You can create a flow record and you can give any name, and then you can use these mandatory fields. So all these match statements are mandatory. We know that we have 7 fields. We have TOS, source IP, destination IP, source port, destination port. We have application number, so you can use these things, and then you can collect counter with bytes and packets. So once you have one user type of record, then you can export that record to this destination. You can use your source as loopback 0. You can use UDP port number 2055. You can use any port number, but that port number should be open inside the firewall. And here you have option, either you can use version 5 or 9. So once you have this record and once you have created the exporter, then you have to call these 2 functions inside the monitor. So I am calling the record and I am calling the exporter. Once I am done with all these 3 things, that I have the record, I have the exporter and I have the monitor, then I can go to the interface or any VLAN interface and I can apply like this IP flow monitor. This is the record name, that is the sample. So I can use it input, I can use it output, I can use it both direction. Okay, so this is very simple to apply it. I'll show you in the next class when I install the switch in my device. In the router you have different way to do this. Okay, so leave it for the moment. Okay, and after that you can use these commands. I'll show you at least 3-4 commands: show, flow, record, monitor, exporter. So record, where you have user based record. Exporter, you can give the source, you can give the destination, you can give the UDP port by which you are exporting the Netflow records, and the monitor, you are calling both the record and the exporter. Okay. Okay, so I'm moving to our last topic, that is the Wireshark, how you can span and how you can take the Wireshark. Now in this particular platform, not only this particular platform, but in this particular iOS XE, we have option. Either we can take the external capture or we can take the internal capture. So let me show you in the Google. So let me open this thing. How you can search? There are very good document inside Google. If you type something like embedded Wireshark, it's a bit slow. Embedded Wireshark. Even you have in 3850 4500. This is the setup guide. Do we have? Okay. Wireshark quick setup guide we have. Let me open that and we'll check that. So there are some limitation as well. What it is telling, Catalyst 4500 series switches with the Supervisor 7 has a built-in functionality in the iOS XE 330. So after 330 you can use this feature in the Supervisor 7. And how you can use this? So use is easy. When you need the enterprise services and you need at least 3. So to take the embedded capture inside 4500, you need at least these things. So you need 330 and above image, you need this supervisor engine, and you need enterprise level license. Now to take the captures, it's very easy. It's only 3 to 4 commands, and these commands are this. So the commands are monitor capture. So the name is mycap, you can use any name. Interface, I am monitoring on gig 2/26 in both direction. Then where you want to save this file? I want to save this file inside my boot flash with the name of mycap.pcap. After that you can start the capturing. So once you start the capturing, after some time, even you can limit the size as well. After some time you have to stop as well. So this is very, very important then command. This monitor capture, mycap, stop. Now please do not worry. I have 2 classes for capturing. So please do not worry. I'll show you, and I have the notepad notes as well that I will share with you, that how you can capture on various platforms. So this thing is common with 3850. So whatever procedure we are following here to capture traffic inside 4500, same is true with 3850 as well. Okay, so this is the way you can capture traffic. If I come to this particular PPT, here also you'll find the same way, the Wireshark logo, and then you will get the example, and then this is very big example, but this is not the way that we are doing this. You can see here in single line he has given everything, but you can break this thing, you can break this thing into the pieces. So you can capture a particular interface that is in the first line, then you can save that file into the boot flash, that is the second line, and then you can start the capturing. So once you start the capturing, if you type show monitor capture, and there are other options as well to check the capture file inside the CLI. So start, it's not like once you save the file inside the boot flash and then you are copying from boot flash to the TFTP or FTP server and then you are checking it. Inside the switch itself you can check like this, show monitor capture file boot flash detail. So it will show you the detail value. The limitation is that you don't have filters like you have in the Wireshark, that you can do the filters, you can go to a specific MAC address or the IP address, but yeah, you can do that. Okay, so this was the short thing about the Wireshark capture that we'll get in the upcoming class. After that, in this particular presentation, you will find the EEM script. I will share this EEM script with you, and when I will discuss 3850 high CPU, then I will share that EEM script with you. And there are some other tools and tricks there in this, and you can build your human network. Then these are the things that you can go through it. So please go through all these things, and ISU process and all these things. TCAM utilization, I'll come to this thing. I have a presentation for this as well, for TCAM resources. Here also you can see that how this ternary content access memory works, but I will come back on this. Verifying TCAM utilization with respect to IP route and the hardware platform. Then it has the unicast forwarding and the MAC learning in case of OSPF, and multicast and all other things. So please go through it. It's a very big presentation. It has 184 slides, and you need a very good knowledge to understand all these features. But my thing was that to make you understand about the high CPU. So let me go to the start to make you understand about the interface link and the PoE devices, high CPU, crash, how you can collect the crash input and open a case with the tag, IOSXE licenses, how you can check the licenses, how you can install the licenses, I skipped QoS, then how you can do the basic stuffs with related to Netflow, how you can take the packet capture. It will come in the upcoming classes. And then the miscellaneous tool is like homework for you. You have to do that by by yourself. If you have any doubt, you can ask. Today I'm going to cover 3850 high CPU, and this is a very important topic, because not only you can solve cases related to 3850, you can solve the cases with respect to 3650. So architecture wise, 3650 and 3850 both are same, and both are using iOS XE. That is the software architecture, and their hardware architecture is also same, and we'll see what are the components that those are making the hardware architecture as well. So let me open the slide. Okay. It is somewhere here, my slides in the other system, and connect to partner. Oh, already connected, established connection. Do I have a connection? Yeah. Okay, so I already have connection. Let me scroll it down and add the size, and let me open the PPT. So as you can see in your screen, this particular presentation is belonging to 3850. Now what is the agenda here? So agenda is very clear in this particular platform. We have to understand the hardware processing or the packet handling. So this Fed engine is nothing but it will do all the hardware processing. This IOSD, that is the iOS daemon, this is the kernel. This PDS and this handle will come to know one by one. So what is the use of this PDS and what is the use of this handle? And all these four things are very, very important. If you understand these four things, you will easily resolve the high CPU cases inside 3850. So let me scroll to the next slide, and in this slide you will come to know about all these components. Now before going to the next slide, whenever you have high CPU is due to either CPU, that is the processing cycle, so the process generated, or the traffic generated, that is the interrupt or traffic. So CPU means maybe your SSH cycles or your SNMP or maybe your stack manager or maybe your other things. You can count even OSPF, sometimes BGP, whatever processes. There are so many processes. Those are handled directly by core, directly by the CPU. So you may have high CPU due to these processes. Even you know that there are some functions like if TTL is less than 1, if you have ACL with the lock keyword, if you have something like MLD snooping with respect to IPv6, you may have IGMP snooping, you may have a spanning tree loop. So all these things, they are governing, they are handled by the main core or the CPU. So if you have high CPU due to these process, you come to know, oh, I have issue with these things. Now coming to this particular thing, that is the interrupt based or the traffic based high CPU. On that case, what will happen, that in these type of platform like 3850 or other switches, you have certain queues defined. So certain queues defined for certain traffic, that will come to know. So suppose in this case, suppose if you have 32 queues, what you can do in this particular platform, that you can check which queue is overutilized, which queue has lots of traffic punted inside the queue. So you can identify the queue and then you can come to know, oh, this is the ARP based traffic, or this is IGMP based traffic, or other IPv4 or QoS or ACL based traffic. That will come to know. But the bottom line is this: either it is CPU generated or it is traffic or flow through traffic generated. So these 2 points. Now going to the next slide. In the next slide, you'll come to know the different type of terminologies, and these terminologies are very important, not only in terms in the term to understand what is happening with the switch, but these terminologies are important to make your customer understand that, oh, your CPU is high due to FED. Now they can ask, oh, tell me what is FED process. CPU is high due to IOST. So what is the IOST? What is the use of IOST? So these things are very important to understand. Now, the software architecture of this 3850 is something that you have iOS daemon, and on the top of iOS daemon, actually on the top of this daemon, you have different software packages like platform manager, other managing stuffs, and then you have L2 daemons and you have L3 daemons, and then you have some other handlers both sides. So this is the rough architecture of the 3850 or iOS XE. Now in this particular iOS architecture or software, you have to understand these four things. So packet delivery system, handler, IOSD, and the Fed, what is the forwarding engine driver. Now IOSD is nothing but the kernel, so you can think as a Linux kernel. Now, what is before IOSD, that is different thing, but after IOSD all the process will get kicked. So whatever kick start process are there, that will be after IOSD. So once IOSD is up and running, then all the process they will start. Now the second important thing is this Fed, and this is like the heart of this 3850. What is the use of Fed? It is responsible for all the hardware programming and the forwarding. Now the term hardware programming and the forwarding means what? So suppose let me open one new slide here. Okay, so suppose if you are doing some configuration, what you are doing, you have this privilege mode, you are doing conf t, then you move to global configuration mode, then you go to interface gig suppose 00, and suppose here you are typing MPLS IP, something like that. So what will happen? This is the command that you are executing via CLI. This CLI, first it will contact with the parser. This parser will check, oh, do I have MPLS IP enabled, and you can check anything, any example. So do I have MPLS enabled on this interface? If yes, then return null, means they will generate some error, oh already MPLS is there, or then do none. It will take no action. If it is yes, if it is no, then it will check the other function. Then it will check, okay, then write this thing to the hardware. Okay, and then the lower programs will happen and it will write to the hardware. Now the parser has tree and they have root structure, something like root, and again down they have some other functions to call, again down there they have some other function to call. So parser is nothing but a tree based architecture to check some commands. So that is the use of parser. So whenever you are writing something from CLI, it will check with the parser and it will execute, means it will check some conditions and then it will execute the command. Now what will happen here when you are using this Fed process, it will do all the hardware programming. Okay, so suppose initially you have, let me give you some other example. So initially on interface gig 00, suppose my IP address was 10.1. Now I want to change to 20.1. So what will happen? This program will erase from the hardware and the new program will take place inside that hardware, inside this gig interface. So all these things will happen by the Fed. This is very a small type of example. Apart from that, what Fed will do, all type of decisions related to hardware forwarding. So I can take one example, say suppose in any of the machine you have two plane. One is control plane, one is data plane. If I'm taking example of IPv4, at that time you have a routing information base, that is the RIB, that is a control plane thing, and then you have FIB, that is the forwarding information base. So whatever information in the RIB, it is again write it down to the FIB, that is the forwarding interface base, and you can think this as a CEF, Cisco Express Forwarding. So 11111 has to map with some MAC address. So from RIB it will write to FIB. Who will do this? Your Fed will do this. Suppose if you have some QoS configuration, so you enable some, suppose auto QoS on certain interface, what will happen? All these things will write it down to the hardware, to the line card or whatever the interfaces you have. So in this case, what you have? Suppose if you are using 12 port 3850 switch, so you have 12 ports and these ports are mapped with ASIC, and again these ASICs have some buffer and they are mapped with the CPU, and then they are mapped with the backplane, whatever backplane is there. So all these things configuration are again written down to the hardware level. Actually they must be here in the ASIC, and again they will map with the TCAM. So Fed, what Fed is doing? Fed is doing nothing but doing the hardware level programming or the packet forwarding. So obviously packet will forward at the rate of hardware. So both are the same thing. You are forwarding the packet, obviously you are using the hardware. So whatever hardware level programming is there, Fed is doing. What iOS daemon is doing, iOS daemon is nothing but the kernel. So kernel will kick-start all the process. Again, I will go inside IOSD and the Fed. Apart from that, you can see that you have other processes as well. So apart from that, you have packet delivery system. This is the architecture and the process of how packets are delivered to and from various subsystems. As an example, it controls how packets are delivered from Fed to IOSD. Okay, so you can think like this, that your IOSD is nothing but a kernel. So kernel is IOSD. It is kick-starting, means this IOSD has several attributes. So it will kick-start OSPF daemon, BGP daemon. Now these are the control packets or control programs. Now these programs, again these programs must be programmed inside hardware. So who will do that? Your PDS will do that thing. So it will sync or it will send the instruction from the kernel. So kernel is the brain actually. So IOSD is nothing but the brain and this FAD is nothing but heart. So you have heart and brain in the switch, and these are the network system to communicate between the IOSD and the Fed. Apart from that, one more important thing is there in this process. What is that? So that is the handler. Now at the moment we don't know about LTL value, that is the local target logic, but the handler is nothing but a placeholder. So what is the use of placeholder? If you know programming, again, if you are typing something integer t and then you are calling some function t, and then you can put t equal to 10, so your value will be t equal to 10. So t is what here? T is nothing but the placeholder. We'll come to know about this LTL value. LTL is, it will come in 6500, but yeah, this is a placeholder, and the use of this, that it will hold some value. So this handler, what handler will do, it will hold some value. You can see here it is a pointer to hold something. So the definition is, a handler can be thought of as a pointer. It is a means of discover more detailed information. So it is a pointer, but it is a placeholder as well. So it will point something, that something is there. Okay. How can I explain this? So I'll explain you this thing. Actually everything is database nowadays. So when you are thinking about the interfaces, so interface gig 0, 0, gig 0, 1, 2, 3 and so on, these are the interfaces that we are seeing, but behind the scene all these interfaces has some logical value in terms of machine, and those logical values are LTL values. So you have some LTL hex value. These LTL hex values will be mapped here, 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 and we'll come to know about this handler that I have something called interface and I have something called IFM. So I have interface manager and I have interface, and with the help of this handler we can check what inside the interfaces. I'll come to this point in this slide. But these are the four main important things. So IOSD is nothing but the kernel which is responsible to kickstart all the program. FET is nothing but you're responsible for all the hardware forwarding. PDS is something you can think that the communicating channel between IOSD and the FED, and handler is a pointer which is holding some important information, so which has a look on the database actually. So whenever you have gig 0/1 to 24, they are actually stored inside database, and with the help of this handler we can reach to that particular interface inside the database. So it is pointing somewhere to the database handler. Okay, so with the basic knowledge of all these things, now we can check the high CPU cases. So whenever you have high CPU, what you are doing? What we are doing actually, we gather some logs. So in this case, you can see that I'm executing one command. The command is nothing but show process CPU sorted exclude 00. Now, because this is dual core, so you have two dual cores, so that's why you have 4 cores. Here you can see that when I'm executing this command, it is showing that I have high CPU or I have a spike in IOSD process, and even my FED process is also going high. So what you will understand with this output, you will understand that your kernel, your program IOSD, it has some functions. Obviously it has the control functions. It has some functions that is not working normally, plus your FED process, that is your hardware programming, is also not normal. But this 12 is actually normal, but still suppose if it is 40 or 50, means your hardware forwarding is not happening properly. So in this case you can see that your control and your hardware both has issues. Now in the notes down you can see from the output it is clear that IOS daemon consumes major portion of the CPU along with FED, which is the heart of box. Okay, when CPU usage is high due to interrupts, you see that IOSD and daemon has major portion of CPU. So what it is telling, that if we have these things like FED, punject, TX, RX, replenish, TX complete, if we have these things, means at that time you have high CPU due to traffic. Now high CPU due to traffic means what? Means FED is your process which is doing hardware programming, means your FED is not able to handle that much traffic, means traffic is coming to your hardware, and because the FED is not able to handle all those n number of traffic, so FED is high, means the utilization of FED is high due to this transmit, receive, replenish or TX complete packets. Now what you have to do, you have to check inside your FED that what exactly happening inside this. But from this output, even I'll show you the next slide as well. So here we come to know that my IO is daemon and my FID is bit high. Let me go to the next slide and I'll show you that how could you check individually IOSD and FID. So the next command or the next option here is in the next slide. Let me open that. Yep. So here you can see, okay. Here you can see in the slide a verb. Let me go to the back. Yeah, in this slide. So in this slide you can see that even you can expand the IOSD process and you can expand the FID process. So IOSD and FID process. Once you expand the IOSD process, what you will get, so what information you will get, obviously I already told you the IOSD is nothing but the kernel which is starting the control traffic related to L3 or maybe L2. Here you can see that IP ARP snooping, ARP input, IP host track, these processes are high, and in the FID you can see that your Punjak TX and RX are high. Okay, so this is related to hardware forwarding, this is related to programs, that is the control programs. Okay, so these two information are again important. Now again, moving further in this slide or example, how could we trace that who is the culprit? Now, before reaching to that particular point, what you can do here, that you can check some important inputs here. What you can check here, now it depends that what type of switch version you have. Maybe sometimes you have 3850, so let me write here 3850 24 port, or maybe you have 3850 48. So if you have 3850 48 means you have two ASIC, ASIC 0 and ASIC 1. So port 1 to 24 are mapped to ASIC 0 and 25 to 48 they are mapped to ASIC 1. In that case, in case of 48 port switch, you have to check the output for both the ASICs. And what output you will check? You will check show platform, punt stats, port ASIC, so 0 or 1, and then the CPU Q, minus L is for Q, direction RX. So this is actually very important command. Let me highlight this. After highlighting, I don't think so you are able to see this. So this command is important, and this is actually very important. So what this command will do, that once you execute this command, it will tell you that okay, I have 32 RX CPU queue, and in these 32 RX CPU queue, which of the queue is highly utilized, means what are the traffics those are punted in this particular queue, what is the more amount or much amount of traffic that is punted in this queue. So you can check here, and for your reference you can see here in the next slide that what is the significance of queue. So once you execute that command, you will get a big output. On that big output you have to see that where you have the more number of counters, so much more number of packets are hitting to which particular queue. So if it is hitting this queue or this queue or this queue, suppose take example of this queue, that is the CPU queue protocol snooping. That means in your switch the snooping, and due to snooping you have high CPU. If you find something like topology control, this is directly related to a spanning tree protocol or BPDUs. That means your spanning tree is not stable, your BPDUs are not stable, you are frequently getting the TCN bits or TCN packets. So these are the reference for the queue. So by which queue your CPU spike is high in 3850. Now again, there are some other commands as well for this to verify, and I think this is one of the most common. Actually, all the commands that I'm showing you, all the commands are very important. So suppose you come to know that okay, queue number 16 is the culprit. So in queue number 16 I have lots of traffic, and queue number 16 is related to, you can refer the table, it is related to suppose snooping. So what you can do, okay, you come to know that your IOSD process is high, your FED process is high. Inside IOSD you come to know that snooping is there, who is generating lots of traffic. Inside FED you'll come to know, okay, Punject TX and Punject RX are generating high traffic. So from here you can come to know, okay, this is okay. So how could you see the queue? Once you identify that what is the queue where you have the traffic, which queue is bombarded with the traffic, what you can do after that, and this is one of very important command that you can check with this output, the show platform punt client. Now the importance of this output is you will get this thing. So it's a very important command to know the tag value. This tag value is important. Okay, so once you identify the tag value, and here you can see the suspended, S for suspended. This suspended means nothing but the that the FED handle is suspended and overwhelmed by the number of incoming packets. So much packets are coming in this tag value. This tag is very important for the next command. So this is series of command. This is one command. The other command is this. So you can filter from show PDS tag all inactive tags and then the tag number. Once you execute this command, you'll get, oh, protocol snooping is very high. Now in this particular output, say this is first, this is the second. Here you will get one important thing, that is the handler. So we know about the handle. Handle is nothing but a pointer. So if you come to know about the handler, it will point somewhere. So we'll check where it is pointing. Okay, to summarize this, once you execute the commands like show process CPU, so process CPU sorted, exclude 00, and the same command with respect to FED and the IOSD. Now you are going deep into the process. After that you can check show platform software and the punt statics for ASIC 0 and 1. From here you'll figure out which queue has high number of traffic. Once you identify that, then the third step is to check the punt client. So with help of punt client you will get the tag value, and with the help of tag value, so once you will execute this command, that is the tag all, and then the tag value, suppose 65561. In the fourth step you will get the handle, that is the pointer. So you can see that we have multiple labels to troubleshoot high CPU in 3850 and 3650. From one label to other label we are moving to check exactly what is punting inside my hardware. So till here I reach till handler. Now what I will do with this handler, that I will check that this handler is belonging to what. So for that, now there are two ways. Once you get the handler, there are two ways to do that. So dump the packet sent to the CPU. Now with the help of the handler, you can execute this command. Show PDS client, then the handler name, packet last sync. Now the only problem with this particular command, that it will capture last packet, and there are chances that your high CPU is not due to that packet. So better to skip this. If you want to make a reference with a step number 1, suppose this is the packet capturing a step number 1, and you have packet capturing a step number 2 as well. Once you follow all the 4 steps, 1, 2, 3, 4 previously, then you can capture the packets, dumps the packet by two ways. One way is with the help of handler. So once you run this command, you will get certain information. Those information you have to decode. Now it's a bit difficult to decode this information. In this particular information, you will get some MAC value. If you trace down this MAC value, that is actually the last step for the high CPU. That is the 5th step. So how to trace down the MAC value? If you trace down the MAC value, how you can trace down the MAC value? You can use this command, show platform port ASIC. IFM is nothing but interface manager. Inside interface manager, you have interface ID, and you have to give this number in hex. So whatever value you got here, you have to put that value, and you can check that you are putting that value. You are excluding 07. Actually 07 belongs to CPU, so you are putting this 64-bit hex value here. So if you type this hex value, because you know that this is something like handler, and handlers are some pointer, so it will point to certain interface. So in this case it is pointing this interface. That means this interface is generating lots of traffic. If you shut down this interface, your high CPU will go down. Okay, so if I scroll to the bottom, you can see here that once I shut down this interface, this will minimize the traffic. Now there are chances, because we get this information with help of handler, and what handler are doing, they are capturing only last packets. So there are chances that this information will not reduce the CPU spike or high CPU. If you want the permanent solution, or you want to do it, you can say in proper manner, then you have to use the concept called FID tracing, and if you do this, you will get exact output. So let us discuss about this FID tracing, and once you do the FID tracing, you are done. You are good to go. You can close the case. Okay, so let me show you what FID tracing is and how we can execute the FID tracing. And actually this is easy. If you make some notes, means some 3 to 4 commands, you will do this FID tracing. So how you can do the FID? FID is itself what? FID is a process for hardware programming and forwarding. So hardware forwarding. Now what we are doing, we are tracing the hardware forwarding. So FID tracing means something like hardware forwarding tracing. So we are doing the hardware forwarding tracing here. Obviously, if you do the hardware forwarding tracing, you will get the exact result. Now how you can do the FID processing, you can see here. And similar to this FID processing, we have netdr in 6500. That will come after some time. How you can do the FID tracing? for that you have to enable the FID tracing. So you can enable with this command, set trace control FID punject detail enable. Once you enable that command, then with the help of this command you can execute this. Show management infra trace a setting FID. Now you don't need to memorize these commands. You can make your notes, you understand the concept, you made some notes, and then you can execute it. So no need to just get by heart all these commands. These are very, very hardware specific commands. In other platforms you don't have these commands. So set the trace control FID, enable the FID tracing feature with help of this command, and other that you can set the management infrastructure setting FID punject detail. So once you execute these two commands, you will get the output. Apart from that, we have some other settings that if you want to set the buffer size for your FID tracing, you can use this command, buffer size and then the buffer. Okay, because by default it will capture less packets, and in your scenario if you want more packets, then you can set the bytes from 8K to 64 MB. Okay, and you have option that you can use either match all or match any. Now how you can add filters, even you have option to add the filters, but no need to do all these things. What you can do, you can follow 3 steps. So you can enable the FID, that is step number 1. You can limit the buffer size, that is number 2, and then you can check this, show management infra tracing FID. Now what will be the output for this particular FID tracing that you will see here? Now in our case, now this is the most important thing here. So what is the use that we have done all those things? Means what is the use that we have seen that I have issue with the queue number 16. This is the use. So in my case, what you have seen that I have issues in queue number 4, 12, 15 and 16. So in the FID tracing, in the same line, what you can do, you can start and you can end. Means you can, whenever you are setting this, that is the common syntax. So suppose I can start with queue number 12, I can end to queue number 16. So it will capture all those queues only if you enable the filter in the FID tracing. Yeah. So set the trace FID inject RX match all. Okay. Just execute this command. In this case, I have executed in the queue number 16. So once I execute this command, I will get output like this. This is again the output with respect to L2 type of output you will get. It's very low level programming output. So it will show you the MAC addresses. Once you have the MAC addresses, what you can do, not only it will show you the MAC address, but it will give you much more detail. So what are the details you will get inside the FID? You have to mark the FFID. So you can mark the tag and you can mark the FFID. Once you have FFID, you reach to your destination. So once you have FFID, then what you will do, you will execute that command that we have executed in the sync area. That is this command, show platform port ASIC IFM FFID, and then this command, once it execute, you will come to know, oh, these interfaces are culprit. You shut down these interfaces and your high CPU will come down. Okay. So there are lots of commands here in this particular platform. What you have to do, please make a notes. Once you make a note, here you can see that it is showing queue number 16. Obviously I captured with respect to queue number 16, so it will show queue number 16. That's okay. The only important thing here is to get this information. So once I have that information, then again I will execute this command and I will get the output, I will get the interface. Once I will shut down the interface, things will come down, means your spike will come down. Okay, so this is it about this particular presentation. Let me do the revision of whatever I discussed with you. So let me go to the start of the slides and I'll come down one by one, so you have better understanding about this high CPU in 3850. 3850, what you have to understand, you go by slide number 1. So you may have high CPU due to either process or interrupt. You can examine both with help of commands, a set of commands. So what are the commands that we are needing? Before that, you must know about IOSD, FED, packet delivery system, and the handlers or the handle. IOSD is the kernel. It is, again, it is also program, but it is doing all the hardware programming and forwarding. PDS is nothing but the communication engine between, or communication media between kernel and FED, means the IOSD and FED. Handler is a pointer that will give you the location where you have high CPU. So handler will give you the location of the interface. Okay. Then how you can collect the output? So you have to start with basic things, and from basic things you will come to know all these things. So I have one, what you can do to collect the outputs. So first of all, you have to collect the output related to these three things at least. See, IOS process, IOSD sorted, FED sorted. Okay, once you collect all these things, then you have to check in which particular queue I have lots of traffic. So for that, what you can do, you can check the output, and the output is this one. This output is again very important. So show platform stats, port ASIC, then the port number and the ASIC number. For example, show platform punt, the statics port, you have to change the ASIC name. So from this output you will come to know which queue is bombarded with the traffic. So once you have that particular output, then you can check your checklist that what traffic or control traffic is there. Then you can do all these tricks. So then you can check the punt client. With the punt client you will get the tag value. With the tag value you can check the process. While you are checking the process, you will get the handler value. With the handler value you can capture packets and you can map with the handler. So with the handler value, you can see here the handler value is 72966672. With this particular value, you can execute this command, that is the last sync, but this is not recommended. So what you have to do, that you have to do FED tracing. So FED tracing is the ultimate way to capture some packets for this particular platform. In the FED tracing, for that I have not, so I'll show you that. In the FED tracing, what you will do, this is the command. So set, first thing you have to do, set trace control FED punjet detail. If you want to limit the buffer size, you can limit that. Then you have to type show management infra trace setting FED punjet detail. Now here what you can do, that you can set the queue length. Even if you want, you can set the buffer size, but this is the third command. You can give your start queue and you can give the end queue. Then you can do this, and with the help of this command you can check the output. So in your screen, show management infra trace setting FED detail, you will get the output. This output will be robust. So in this particular output you will get all the information what you are looking for. So all the information what you are looking for means you will get this hex output. In this hex output, you'll come to know what is the if ID. This is the thing that we are looking for. So once we get this information, then the last command to execute is this one, this command. So you have to execute this command, show platform port ASIC and this, and it will show you the interface from where the traffic is punting. Okay? So this is the step that you have to follow in this process. If you have any